Hi friends, this is Rishi and welcome to your favorite YouTube channel Science with Rishi. This is the second video of the chapter number 3, motion in a straight line, and today we are going to deal with the topic instantaneous velocity. Okay, in the last class actually we were studying about what is the velocity for a given period of time, right? But in this topic it is not for a given period of time. What is the velocity of a car or whatever that object be? What is the velocity at a given instant? Okay, for example, at 4 seconds, what is the velocity of that object at t is equal to 4 seconds or at 4.7 seconds? Okay, here in this textbook they are explaining how to find out the velocity at a given instant, which is called the instantaneous velocity, in two methods. One is numerical method and one is graphical method. And in your textbook they are explaining the graphical method first and numerical second, but I prefer to take it in the reverse order, to explain that numerical method first and then the graphical method. Okay, in your textbook they have given an example that an object, let it be a car, okay, that car is moving according to an equation x is equal to 0.08 t cube. Okay, now what does this equation mean? It means that the car is moving according to this formula. Let me explain it. At time t equal to 0, okay, let us write t and x here. At time t equal to 0, x is 0.08 into t cube, which is 0 cube 0. Okay, now you have started the car and simultaneously you have started your stopwatch also. Now after 1 second the car has reached 0.08 into this 1 cube, which is 0.08 meters. Now similarly for at time t is equal to 2, it has reached 0.64 meters, and at time 3 it is 2.16 meters, at 4 5.12 meters, at 5 seconds it has reached 10 meters, and at 6 seconds it has reached 17.28 meters from the starting position, and this continues. Okay, now what we have calculated here is the distance or the displacement from a starting point. Now you have been asked to find out what is the velocity at exactly 4 seconds. Okay, what is the velocity at exactly 4 seconds, which is the instantaneous velocity. Now I request you people to write it down in your notebook because I want to remove it, and I'm going to show you how to solve it in numerical method. So please write it down. Now you know velocity is simply the distance traveled by the time taken, right? And you have been asked to find out the velocity at 4 seconds when the object is moving according to the equation x is equal to 0.08 t cube. Okay, now for 4 seconds let's take 1 second to left and 1 second to the right side. So here let us take t1 is equal to 3 and t2 be 5. Now you know what is the distance at time t is equal to 3 seconds. What is it? 0.08 into 3 cube, which is 2.16 meters, and similarly for 5 seconds it is 10 meters. Okay, so for this 2 seconds, please listen, for this 2 seconds, which is the delta t, what is the distance traveled? It is 10 minus 2.16, right? So in 2 seconds this one has traveled 7.84 meters. And what is the velocity? This 7.84 divided by 2, which is 3.9 meter per second. Okay. Now let's reduce this delta t. Now it is at 2. That means 1 second to the left and 1 second to the right. Let us take delta t to be 1 second, which means t1 is 3.5 seconds and t2 is 4.5 seconds. Okay, substitute it in the same equation. Instead of 3, it became 3.5, and instead of 5, it became 4.5. We have narrowed down the time interval. Okay, this will give you 3.43 and 7.29. Okay, and what is the distance traveled in this 1 second? It is 3.86 meters. And what is the velocity? This 3.86 divided by 1, 3.86 meter per second. So we have narrowed down the time and we have found out all these values. Now we are again narrowing it down to 0.5 seconds. Okay, 0.5 seconds. So what does that mean? 3.75 here and 4.25 here. 0.25 second to the left and right of t is equal to 4 seconds. Correspondingly, the distance is 4.21875. Just substitute it here. That's all. Nothing else. Okay. And 6.14125. Distance traveled is 1.9225 meters. And velocity is this 1.9225 divided by 0.5, which will give you 3.845 meter per second. Okay, the time period was 2 seconds, narrowed down to 1 second, again narrowed down to 0.5 seconds, and we are again narrowing it down. We are taking it to 0.1 second, which means 0.05 second to the left of 4 seconds, which will give you 3.95 here, and 0.05 second to the other side, which will give you 4.05. Okay, correspondingly substitute in the same equation 4.93039 and 5.31441. The distance traveled is 0.38402 and velocity is 3.8402. Okay. Now let's narrow it down again. 0.01 second, which means 0.005 seconds to the left and right, which will give you 3.995 and 4.005. Substitute, it will give you 5.100824 and 5.139224. The distance is 0.0384 and velocity is 3.84. Okay, so hope you have understood how this table has been made. The same table is there in your textbook also. See, we have been asked to find out the velocity at exactly 4 seconds. But what is velocity? It is a distance traveled by time taken. So there must be a small range of time, right? But to calculate the instantaneous velocity, we are taking that time very small. It is we are taking it maximum close to 0. Okay, here earlier it was 2 seconds, which we reduced to 1 and later to 0.5, then to 0.1 and then to 0.01 second. Okay, so what does that mean? What is the distance traveled by the object in a time period of 0.01 second to both sides of t is equal to 4 seconds, right? Now you can, if you want, you can again take it down to 0.001 second, by which this T1 and T2 will become 3.9995 and 4.0005, by which you are more close to the instantaneous velocity at t is equal to 4 seconds. Okay, what we are doing is we are taking this delta t maximum close to 0. Now let me write that equation. Instantaneous velocity is limit delta t tends to 0, right? This is 0.01 second, which is very close to 0. The distance traveled in that time divided by the time taken. Okay, hope this is clear, at least now, when we are solving how to find out the instantaneous velocity in numerical method. Now let's do the same thing in graphical method also. Now when doing it graphically, we know x is equal to 0.08 t cube, and we have made a table for x according to time. When time is 0 to 6 seconds, what is the distance, right? And that table I have made graphically, and this is how that graph looks like. And you have almost the same graph like this in your physics textbook also. Okay, now what did we do in the numerical method? In the first case, we took what is the distance at t is equal to 3 and t is equal to 5, right? Now if I join a line like this will give you 2.16, and this 5 is giving you 10. Okay, now to find out the velocity, we know these 2 points, time is equal to 3 and time is 5. Just draw a straight line joining these 2 points. Okay, draw a straight line. You just consider that this is a straight line. Okay, this is not so straight, but just imagine that this is a straight line. Okay, now we have made a straight line here, and the slope of this line will give you the velocity when the object is moving between time 3 and 5 seconds. The slope of this line, let us take it as a and a dash. Okay, now let's take the next case. We are narrowing down the time. What is the second case? The time is 3.5 and 4.5, right? 3.5 and 4.5. We are taking it for 3.5, 4.5, and just and you just join it here. This is 3.43 and this will be 7.29. Okay, this will be 7.29. And what should we do now? We have to join these 2 points, right? This B and B dash. Make a straight line. Okay, in this case you will get the velocity between the time 3.5 and 4.5. Now if you go on narrowing the time period, you will get a line which is at 4 seconds. Okay, and that line is the tangent drawn to this graph at time t is equal to 4. Now what do you mean by tangent? Okay, tangent is a line drawn to a curve, and that line is going to meet that curve at only one point. Exactly one point a tangent will be meeting a curve, and that one point here is t is equal to 4 seconds. Okay, this point. Yes, it is little bit difficult to draw and represent in a graphical method, but this is just to make you understand the concept. What is the instantaneous velocity? Instantaneous velocity is the tangent drawn to the curve at the required time. Okay, and the best method to find out the velocity, the instantaneous velocity, is using the numerical method itself, which you might have understood by this time. Here also you can write limit delta t tends to 0 delta x divided by delta t. Here we have first we have taken the time for 3 and 5, then we have reduced it to 3.5 and 4.5. You can again reduce it, but actually the problem is to draw each and every line in this graph. It will just make everything dirty. So that's why I have stopped at 3.5 and 4.5. And similarly, if you go on reducing it, you will get a line going at exactly t is equal to 4 seconds, and that will be a tangent also, and the slope of that tangent line gives you the instantaneous velocity at t is equal to 4 seconds. Okay, hope this is clear for you. So that's with the instantaneous velocity part. I think you people certainly need a break here, so I am also winding up this video, and I strongly recommend you people to go through the text once you have finished with this video, so that you will be very much clear with the concept. And what my plan was to take the acceleration also in this video, but I think this is more than enough for today, and I will come up with the same topic, acceleration, in the next video. Until then, Rishi signing off. Bye, take care, Jai Hind.